Welcome to the session. Greeting of the day. In this class we are going to see about the welding arc initiation methods. How the arc is generated. We came to know we are going to weld two pieces, a positive welding process, and the electrode is going to melt and deposit it. But how it melts? We need the heat sources there, it should be melted. So therefore we are going to generate the heat in those locations between the electrode and the workpiece. But how we are going to generate the heat? That is through the arc initiation method. We could have seen during welding process the arc is generated and those arc generates the heat, and therefore this heat will help in melting of the electrode. But how this arc is generated, that we are going to see now. So welding arc, it is an electric discharge due to flow of current from the cathode to the anode. So the flow of electron takes place from the cathode spot to the anode spot. This flow of electrons, this flow creates the heat in the middle of the gaseous zone. It is nothing but the region which is in between the workpiece and this electrode. So we are going to weld, we are going to generate the heat in this zone. We are going to generate the heat in this zone. So the electron flows from the negative end to the positive anode workpiece. So here this flow generates the heat, that the heat obviously melts the electrode. So flow of current through the gap between the electrode and the workpiece needs a column of charged particles to make. So charged particles is nothing but a flow of electrons. That is the electron we have to create. How should create them? It is there. Every material contains the molecules which contains the atoms and electrons. So these electrons to be ejected outside the electrode. That ejected electrons to be absorbed by the workpiece. Then automatically the flow creates the heat. Before going there, few important points we should keep remember. We are going to talk about these voltages and current and then the polarities. These words we are going to use now in the welding. Voltage, current, polarity, electrical circuit, electrical terminology, those things in general we should see. So what is voltage? It's nothing but the electrical potential or pressure that causes the current flow. What I am doing, you should keep remember, the voltage is nothing but a pushing of electron. I am giving a pressure, I push from the electrode. Electrode contains electrons. The workpiece contains the atoms and electrons. So I am going to push this electron. The flow of electron creates the heat. But I want to make it to flow. How? I am applying the voltage which pushes the electron. Voltage is the electrical potential or pressure that causes the current to flow. It should flow more. Then from where it flows, you should push, then it moves. If you are not pushing, it won't move. Therefore, it is a flow pushing of electrons. So the current, the movement of charged particle in a specific direction. So I am writing here, this current is a flow of electrons, and I am writing that the voltage is a pushing of electrons. Pushing of electron. I am started to move, pushed out from the electrode, and it moves and flows to reaches the workpiece. So voltage, pushing of electron, current, flow of electron. Likewise we understand. So now we come in accordance with the polarity also. So the DC represents the direct current, alternating current is there, direct current is there. So alternating current, the cycle waveform differs, but direct current is straight. So that we know this. So direct current, the electrode is negative. I am making the electrode connected to the negative zone. How I am making? So I am making the workpiece like this, and here I did, and I am connecting this electrode to the negative spot. Right? So this I am connected to the negative spot of electrode, and in the workpiece I am connected to the positive spot. So I am calling this as a straight polarity. In such case only the flow of electron takes place from here to here, it flow. This electron flow generates heat. It impinges the arc zone between this gap. It impinges this electron forcefully impinge into the gaseous zone which is available here. This impedance creates, this attacking force creates the heat. It means the gaseous molecules resist the flow of electrons from the electrode. This resistance automatically creates the heat. That heat we are going to use. So similarly, DC, this is DC negative, this is DC positive, direct current, electrode positive. So I am keeping this electrode as a positive. Here electrode as a negative. This electrode is kept as a negative. DC, you can write here. DC, electrode, negative. So in case I am connecting the positive, DC electrode, positive, we will come to know why we are connecting negative and positives. So similarly alternating current are there. So electrical circuit, how we are connecting electricity flows from the power sources. Yes, I am taking the same circuit. So I have the electrode here and I have the workpiece here, right? So I am connecting the negative to electrode and positive to the workpiece. What happens? Electricity flow from power source. The flow from the power source through the electrode, and where it reaches? Through the electrode and across the arc zone and through the base material and back to the power sources. Okay, this is a cycle. And connecting positive, we have studied these things in basic electrical. We are connecting the positive negative, the current flow occurs. Therefore, if I am connecting the bulb here, what happens? I am connecting the bulb here, it blinks. So I am closing the circuit through the power source, through the battery like this. So in between, I am disconnecting and creating a resistance. The disconnecting makes the heat. That heat I am using for melting. But when the circuit is closed, we can able to get the power source outside. But I am making the heat here by making the resistance and making disconnections. That such possibilities we are doing. Electrical thermal energy. This electrical energy we are supplying converted into the heat thermal energy, or created by the electrical current converted into heat because of the resistance of the electron flow. So the word clearly mentions because of the resistance of the electron flow. Where it is resisted? It is resisted on the gaseous molecules present in this zone. Air is there in between. Here there is surrounded us. Similarly, the air is surrounded those electrode and the workpiece also. Those regions, when the electron is released from the electrode, it resists. Gas molecules resist. That resistance it should cross and then it should go down to the workpiece. So that resistance creates the heat. So the heat melts the metal to fuse it together. So this heating cannot be maintained or cannot be withstood by the electrode because it is a low melting material. We are pushing the voltage, electrons are released and it is resisting by the gas molecules in the air and it cannot go, it generates the heat and obviously the heated zone is this region. This is the heated zone. Then automatically it heated and comes down and deposited and become a positive welding process. So simple. Arc generation methods. So likewise, the cathode and anode, the words which we are getting remembered. Cathode represents the electron, it is light and heavy velocity. When comparing to the ions of positive and electrons of negative, we are connected. This is cathode, I have connected to negative. We can able to get a supply here. Okay, this is negative, this is positive. I am connecting like this. Okay, so this negative releases the electrons and positive connection releases the ions. What happens? These ions will be attracted by the negative electrons will be attracted by the anode side, that we know. In between this region we have an air molecules, gaseous zone. Here the resistance happens. Okay, so we remember now. Cathode electron, light and heavy velocity. Electrons are lighter than, comparatively this electrons are lighter than the ions. Okay, this point you should remember, because due to the heavy ions, which is heavy, this cannot make a flow high speed, but electron can come impinge quickly into the workpiece. From here it comes down and hit. Therefore this heating occurs. So we will come again. On establishing the welding arc, there is a drop in the arc voltage. How much we have given? Electrons are not ejected as it is. We are giving a push. That push I am making arc voltage of nearly 40 to 100 volts. Right? Likewise, we are first initial pushing we are doing. Then normally we can able to maintain. So across the arc gap, this drop in voltage varies with the distance from electrode tip to the welding pool. So what happens? I am dividing these 5 zones. The electrode drop happens, we understand. Let us consider. So we will go to the next slide. 5 zones in this arc gap are cathode spot, cathode drop zone, plasma zone, anode drop zone, cathode zone. These 2 are same, and this one is separate, and these 2 again are same. Cathode spot, cathode drop zone, plasma zone, anode spot, this is anode spot. So likewise it is there. So we see. So this is what I told you. Here I connected the cathode, which is negative. So negative, and this is the anode, which is positive, right? And now here I am pushing the electron from here. This point I am pushing the electron, and it comes down. When the electrode I have given 20, let us consider 40 volt has been given there, or 100 volt has been given there for the pushing. Normally the machine setup runs at a 24 volt, 25 volt, 35 volts. But for pushing of this electron we need more potential we need. Let us consider 200 volts are given, 500, such a higher voltage than the normal running conditions we are giving. So when we are giving those things, this electron is released. After releasing, what happens? I am comparing the same with respect to voltage drop. So here it is like this at the cathode, and this cathode drop zone, here it reduces again, the voltage reduces. So it comes like this. And again plasma zone, because we are releasing here, when a ball thrown from the hand, it start with high speed, but when it is reaching the long distance, the speed reduces. Similarly, here having a high voltage, when it keep on going downwards, the voltage also decreases. Okay, so that is how. So I am classifying here about the 3: cathode zone, cathode drop zone, nearer to the zone which is nearer to the cathode, and the plasma zone where the high heat is going to generate, and then the anode drop zone. Then there's a anode. So this is what I have told you earlier. This is how this voltage drop occurs. This voltage drop occurs due to the various reasons of maybe the conduction, maybe the conductions, maybe the radiations, conduction due to thermionic emissions. So conduction, radiations will happen there in between these workpieces. So in between this workpiece, I have connected a workpiece here, and the electrode cap is upper. That happens. See, the radiation happens here, right? The conduction happens here. Every zones are there. See, here also radiation is happening. This creates a atmospheric interaction and simultaneous the cooling process of this heat generated pushing of electrons. Therefore, automatically when it is here, the voltage is high, and keep on coming, the voltage reduces. That is what I have dropped here. How I have divided the zones? I have divided the zones into these categories: cathode, cathode drop zone, plasma, and anode drop zone. See? Likewise, we can superimpose those images here. First, the cathode drop zone, I have here, this is a potential difference volt. Let us consider we have 100 volt here. Okay? When it comes down, it reduces. From this part, it reduces. And potential drop in the plasma zone here, again it reduces. Again it comes down. Again in the drop zone, again it reduces. So this voltage getting dropped, it should not drop. We should give more, keep on, more voltage should be given to successful reaching of electron released in the cathode spot to the anode spot. Then the heat generated reaches the workpiece and it goes. So this is what is happening. Okay, so we should, at the initial stage we are pushing out. When it comes to the atmospheric, the gaseous zone, it automatically collision happens between the gaseous molecules and the electron released. Therefore, this heat generated and this heat makes the melting of the electrode automatically deposited, welded. So that is what. Okay. The cathode spot, I am defining the names to the every spot. The cathode spot, cathode drop zone. This is relatively a very small area of cathode zone. This is very relatively small area of cathode zone. On the cathode surface, emit the electron. So this word is very important. It emitted electron. Now electron is released. Cathode drop zone. It is a gaseous region adjacent to the cathode. Okay. Adjacent to the cathode. Where it is a cathode. Here the electron is released. Here the electron is released now. Right? And it is a gaseous region adjacent to the cathode. This row, first we have talked, okay. The second one we are talking now. So here the cathode drop zone. Voltage is getting the reduction. We understand from the previous graph. So the voltage drop is necessary as the electrons are to be pulled from the region. Electrons are pulled from those region. Which region? From the one, this electron should comes down and then hits here. I have talked to you, these electrons are lighter in weight and these ions are heavier. Therefore, this attraction process is started. These electrons started to accumulate over these workpieces because it is lighter in weight and it can travel very high speed. So this point is very importantly you should listen. So the electrons started lighter in weight with high velocity, comes down and impinge over here. Impinge over here. Okay, but ions are heavier, cannot move with high velocity, and but it causes the flow of current, causes the conductivity. But this heat is generated by this high velocity electrons impinging downwards to the workpieces. Okay, so that is why I have found flow of ions, flow of electrons. Flow of ions in the upward direction I have mentioned. So see this point. Flow of electrons I have mentioned the arrow downwards. Flow of ions I have mentioned the arrow upward direction. So from positive attracted by the negative zone, but negative electrons are attracted by the downward. This attraction process creates the term named as a plasma that we see again. See the plasma zone. This is the visible portion of the arc consisting of hot ionized gas. What is this ionized gas? Ionized gas is nothing but these zones where this collision of electrons and ions happens. Due to this attraction, it mingles. But there is a resistance in between this air gap. There is a resistance due to this air gap. And these gas molecules also will be subjected to this ionization process. So what happens then? This heat generated, due to resistance, the heat generated, that zone, that is the region where the charged particles, the electrons and ions are combined to become the charged particles, are generated here. These charged particles is nothing but a heat. We are naming this as a plasma. A charged particle, we are naming this as a plasma, which is generated by the collisions of electron flow from the cathode to the anode, and the ions flow from the anode to the cathode zone. In the middle, the collision happens between two. So see, positive negative attaches, positive negative attaches. So this zone is called as charged particles, and this created the plasma. Plasma generates the heat. This heat melts the electrode, and melted electrode deposit to the downwards. Very simple. And we can draw here. Okay, two are there, and electrode is there, and it should generate the flow. And we have this electrons here, and we have the positive, and we have this. We have the positive ions here. Okay. So when it comes nearer, these electrons and this positive will mingle together. Okay. But and also we have these gases are there, gas or air are there in interaction between the atmosphere. This also contains some electrons. This also contains some positive ions. Okay, this electrons released from here. These electrons which is released from here, which also interact with the positive ions which is in the air. Okay, this collision happens and this creates the plasma. Okay, so this cases also gives the changes of the heat. So this is also to be considered. That is why I am telling this electrode arc length to be maintained minimum. So what I can do from instead of this point, I can do a minimum maintaining of the electrode. So simply here, I can able to create the arc by maintaining the small gap. There will be no disturbance by these gases and air molecules. So what we planning? We are planning the electron release from the electrode, and it should reach the workpiece. In middle, what happens? This arc length of a air gap disturbs us. This creates the electrons, this creates the ions. Okay? Therefore, that creates the resistance. Increases the resistance. If we increase the resistance, what we have to do? We have to give more voltage will be there. Okay. Therefore, I'm minimizing this arc length. Automatically resistance reduces. Automatically voltage also reduces. So this is the idea. Okay. So the arc length reduces. Resistance reduces. Therefore, the voltage also you can able to reduce. So these things you should keep remember. So arc length affect mainly by as increasing the arc length. What happens? I told you this is the arc length. This gap is the arc length. I told you. When arc length increases, what happens? Arc length increasing decrease the temperature and heat losses. Right? So now the anode drop zone. We come to the next one. See, we are talking about this, and anode drop zone. Keep on voltage is decreasing. Due to the high voltage, we have released the electron here. That part is over. And later we no need of that much high voltage, because electron is released automatically. Here, plasma started to generate. It means the released electrons are getting collision with the gaseous molecules present between this air gap of workpiece and the electrode, and therefore this heat makes everything. Okay, the anode drop zone. This is the gaseous region, and adjacent to the anode. What is this? It is also the gaseous zone. Here, above the workpiece is gaseous zone. It means air zone. Below the electrode is a gaseous zone. That is nothing but an air zone. So this all belongs to the air zone. This all belong to the air zone. So I am talking about anode because anode is there, positive is there. This is the anode drop zone. We are naming, why is it the word drop? Voltage is dropping from the top to bottom. So that is what I have mentioned here. See, voltage is dropping. Here cathode drop happens, and here the anode drop happens because the voltage are getting reduction because the conductivity is increasing. Okay, so what happens there? This is the anode drop zone, and at last we have anode. 2 points are here. So the gaseous region is adjacent to the anode surface. When the surface sharp drop of voltage happens, sharp voltage drop has happened by the graph. This is because electrons have to penetrate the anode. The electrons released from this zone have to come and impinge here. That is what heat. Then the circuit has to be closed. The electrons should flow there through the circuit. Okay, so electrons have to penetrate the anode surface after overcoming the repulsion of the thermionically emitted electrons from the anode surface. So it should overcome the positive attraction by this workpiece. That is what anode spot. This is the area on the anode surface where the electrons are absorbed. So here the electrons are finally absorbed. Okay, heat is generated, electrons are absorbed. This heat melts the electrode and comes down. This one is a longer cathode spot. We are releasing here the electron by giving the high voltage. It comes down. Here this region ionization happens. The plasma generated, which generates the heat. This heat makes the melting of electrode. It comes to melted. But what happened to the electron? The electron comes down and flows. Okay, very very easy. Well, now I'm just simplifying. By simplifying many things, when the current flow on the gap between the electrode and the workpiece, the resistance is caused by the collision of electrons. See, the name resistance. If you are understanding, it is very easy. The current flow on the gap between the electrode and the workpiece, therefore the resistance is caused by the collision of electrons. I told you collision of electrons and the ions happens with the atom inside, which generates the heat. Fine. This is what I am continuously telling. This is 3 lines: cathode spot, cathode space, drop zone, plasma, anode space, anode spot. That is what I am given simply. The flow of current between the electrode to workpiece, which resist caused by the collision of electrons and which generates the heat. That heat we are using for welding. So now this how to calculate this voltage, and I am calculating power of the arc P equal to VC, VP, VA. Voltage of cathode, voltage of plasma, voltage of anode. I am adding this. Simple. Power arc, how much we should give, how much arc voltage should give. Total V equal to VC plus VP plus VA. So likewise, that we call as a power of arc. Arc power is nothing but arc voltage. Okay. So for our understanding, I have given. So red color electrons are comes down. Yellow color positives are goes upward. But what happens? This is the cathode drop zone. See, now we can understand clearly. Cathode drop zone, arc color, this is called as plasma, anode drop zone, anode. So what happens here? I am comparing that same graph here. Here the highest voltage is there, arc voltage. So here it keeps on coming as per arc length. What is arc length? This zone, how much the gap we have, how much the gap this have. If it is very nearer, don't need of that much voltage. It has to be given 100 volt. No need. I can able to give 20 volt because pushing of electron is enough. There is no drop here. Cathode no drop, plasma no drop, anode no drop. So when the arc length is increased, this is the arc zone. When the arc length increases, voltage also increases there. So here it is also increasing. So simple understanding. Okay, so this then only we have talked about this. Electrons are emitted, the free electrons, and recombination happens. This positive happens, which creates the plasma. So this we call it as a ionization process, and then it comes down, and the electrons are absorbed here. Very simple. Now, further we make it. Electrons flow from where? Cathode to anode. We know this. Cathode to anode it goes. Electron flow from cathode in high velocity. Yes, we agree, high velocity, and thus high heat at a reaching side of the anode. Which if it goes in high velocity, it has a force. Then high heat is impinged over the workpiece anode side. Therefore I am telling high heat opposite to the negative. High heat opposite to the negative. Where I have connected the negative? I have connected the negative to the workpiece, and I have connected workpiece as a positive. So likewise only I have connected, you know. So likewise only I have connected. So negative is connected here, electrons are released here, it is high velocity, then it comes and impinge over the workpiece. So what happens? High heat impinging takes place at the positive end. Electrons released in the negative end, high heat generated in the positive end. So that is what I have given, opposite to the negative. High heat opposite to the negative, opposite to the negative. Where we are connecting the negative, there releases electron and reaches the positive side, attracted. Then electrons having light weight and high velocity, it goes towards the positive. The positive end only receiving the heat. Positive end receives the heat. Always a high heat and high melting at the positive. Therefore I am telling always high heat and high melting at the positive side. Electrons comes from the negative and goes to the positive and melts there. Okay, please remember this point is useful in the manual metal arc welding. We should see in which polarity we are connecting. Direct current electrode is negative or direct current electrode is positive. That we should remember there again. Okay, so as of now I am telling when the electron opposite to the negative part receives the heat, therefore high heat is generated at the positive. The same point you will use in the manual metal arc welding again. And every welding process the polarity is needed. Here I have given the polarity, direct current electrode positive, Here electrode melts more. Where I have connected the positive is connected to the electrode. Where the electron comes from the negative to the positive. Therefore where the heat is finally received, heat is received to the positive end. Then where is the positive? Positive connected to the electrode. Electrode is in the positive. Therefore electrode melts. So this is an example of SMAW. Okay. So electrode is negative, workpiece melts more. When the electrode is negative, heat comes to the workpiece. So workpiece melts. Obviously you should attach a filler wire in between, and it also melts there. So I am calling a TIG process here, TIG welding process. This also you should remember. We should see there. Right. Now we know electrons are emitted, but how to emit? There are two methods are there. Free electrons are needed between the electrode and the work initiating the arc. Yes.
These charged particles are generated by three mechanisms of thermal emission, field emission and secondary emissions.
But what is the two methods? One is thermionic emission I am doing. Increasing the in temperature on the metal increases the kinetic energy of the free electrons. As the temperatures increased on the electrode, the kinetic energy on the material of the free electrons are higher, and it goes beyond certain limits. Okay, and electrons are ejected from the material. What I simply am doing, I am supplying this current to the electrode. This electrode itself has some resistance, and this electrode itself resists the flow of current, and therefore when it is higher than that, this releases the electron. That is called as thermionic emission. This releases electrons, we should reach to the positive side. You know this. Now only we have seen. So this is how I am doing. You see, increasing the temperature of metal increases the kinetic energy of free electrons. Increasing the temperature. How I am increasing the temperature? Just supplying the current there, supplying of the current inside the separate electrode. Then it heated, resistance, heated, electron released, and this electron released will go to the other end. Okay. So the temperature at which thermionic emission takes place, most of the metals melt. Therefore I am using the tungsten, which is having the high melting point. If it is heated, kinetic energy is generated, but at the same time, at the other end it melted, no use. Therefore, the electron to be released, that the electron released point should not melt. Therefore, I am using the high melting material of tungsten, which have the 3442 degrees centigrade of a melting point. Then what happens? 1500, 2000 degrees, kinetic energy is increased. Automatically, electrons are released. These released electrons are forced towards the anode. Therefore, the heat zone generated between the electrode and the workpiece. This electrode is a tungsten, and it won't melt as the melting point is high. Electrons are released, heat is generated, and it is melted, and you can use the positive melting process. Very simple. Okay. One more method is there. One we have seen as a thermionic emission. One more is a field emission. In this approach, the free electrons are pulled out of these metal surfaces by developing the high strength electromagnetic field. So the discharge is produced between the electrode and the workpiece. So what I am doing, electromagnetic field is created between the positive and the negative. So here electromagnetic field is created between this positive, see the positive and the negative. Due to this field, these electrons are forced towards the other end. Okay? So easily you can able to generate heat without making the thermionic emissions. See, here the electrons are make the force of going upward direction. So what happens here? These free electrons generated or can able to move in the other end. Very simple. In this approach, the free electrons are pulled out of the metal surface by developing high strength electromagnetic field. Developing the high strength electromagnetic field. So the discharge is produced between the electrode and the workpieces. Electrode is here, workpiece is there. The discharge takes place. Automatically the electrons will move other end. So in this method also, see the high potential difference of 10 to the power of 7 volt between the workpiece and the electrode is established. I told 20 volt to 40 volt it is no. It actually 10 to the power of 7 volt has been given to push the electrons. Then there is no need of this heating process. Automatically the release of electrons happen due to field emission methods. If electrons are released, that is okay for us. After releasing of electrons, automatically this attraction process takes place from the cathode to anode. Cathode drops on plasma, anode drops on. This all happens, but electron to be released first. For that intensive process, we are doing this thermionic emission process, this field emission method. Okay. One is by heating. One is by heating the specimen, and one is by creating the electromagnetic field. One is by creating the electromagnetic field in between these two. Two means the workpiece and the electrode. So this is how we can able to do. And one more option is there of secondary emissions are also possible. What is the secondary emission? High velocity electrons moving in the arc gap collide with the other gaseous molecules. In arc gap, that is nothing but atmospheric gases. What we have did, you see, we have created the workpiece here. We have to weld, and we have generated the electrode here, and this due to thermionic emission or due to the field emission, two conditions, electron is released here now. Electron is released here now, right? And we have connected this end to the negative and this end to the positive. That we know. This also we know. But this is the air gap in between these two. Due to this air gap, what happens? Due to this air gap, these air molecules will also interact with this electron. See, this positive have this metal have the ions, this positive, and this both are mingled. And also
the air molecules which contains electrons and ions will mingle with the plasma and decomposes, and disturbance takes place.
So I'm coming further. So this heat generation arc initiation is okay, but how? There are two most common used methods initiated by the electric arc, namely touch start method we have done in our laboratory. We are going the electrode and we keeping touching this. During this touching process, the circuit is closed. This positive negative circuit is closed. So manual, we are using those in the manual SMIW process. We have seen in shops. Field start, automatically it start. This is what I told you, field emission. Okay, automatically it is starting by releasing the electromagnetic field. So we see one by one. Touch start method. In this method, the electrode is brought in contact with the workpiece and then pulled apart to create the very small gap. What I am doing, workpiece is there and I am coming down, I am having a touch here. Due to what happens, if I am touching these connections, this circuit is closed. Until I am not touching, circuit is not closed and the voltage is, I am not giving high. Normal voltage is there. Let us consider of 20 volt is there. 20 volt is there and I am just touching. Automatically the voltage from the cathode side, the electrons are released and comes here. So here the electrons are released and comes and reaches here and therefore it goes. The circuit is closed. We no need to give high volt. This potential difference, no need. When we are touching, automatically the electrons are released because there is a contact between positive and negative. Automatically this attraction force happens. Therefore, easily we can able to do without giving this a high voltage initiation process. That field emission, no need. Okay. So this is what. Otherwise, what I can do, some other process, I can able to scratch. This everything we have seen. Whether we have to touch for closing of the circuit and we have to maintain for making of the arc gap. We should maintain the small gap between them. Then only the arc is generated. Otherwise, it is stuck there. Okay. Otherwise, what I can do, I can able to make a scratch and also then maintain. Just like the touching and keeping out or scratching and taking out. Making the small, maintaining the gap. So touching of the electrode causes, the touching of electrode causes the short circuiting and so flow the heavy current causes the heating process. Partial melting of the even slightly possible. Okay, this is one method. So what I did, I touched it there. Touching makes the current passing and causes the potential difference and the charged particles differs. Thermal ionization makes the release of the electron. So what happens when I am touching here? This is in neutral. Workpiece is in neutral condition. When I am touching, the circuit closed. Therefore, these electrons are changing takes place. Therefore, the potential difference also occurs. Due to this potential difference, the charged particles interchange themselves. Electrons goes there, positive ions comes there. This interchanging process comes there. So that is called as a thermionic emission takes place. What happens if the electrons flow happens? It is heated. Electron flow happens, that causes the heating process. If the heat occurs, automatically those melting can be done. Okay, that is what. Next one. So the pulling of the electron apart from the workpiece, flow of current starts through these charged particles and the movements of the arc are developed. So here, to use the heat of electric arc for welding purpose, it is necessary that after initiating of the arc, it must be maintained and stabilized. So we are maintaining, we are touched, okay. Short circuit, okay. Electron and positive charges, interchanging potential difference, okay. Thermoionization process, okay. After that, it should be maintained in between with a small gap, not a large arc length. That is what I told you, large arc length is there. Not good. Small arc length for the releasing of this electron to reach their workpiece. And then we should be stable, maintained to be there. Otherwise, it will stuck there. Okay? So that should not happen. Therefore, we are maintaining a small arc gap in between these two. Now you see the other method of a field start. In this method, high strength electric field, this belongs to the field emission. This belongs to field emission. We are not going to touch, but we are going to apply more voltage in such a way electrons are released from the electrode and these released electrons will go to the workpiece. Earlier, we have not made the higher potential, higher voltage, but we are touching. The touching itself causes the releasing of, exchanging of electrons and ions. But here, this electron should comes from the top to bottom. Therefore, it makes the 10 to the power of minus 7 volt is applied between this electrode and workpieces. So the electrons are released by cathode to the field emission process. So what I am doing? So such cases I am not doing high potential difference only simply. Simply I am not touching. Earlier class we have used the touching method, but here I am not touching there. Simple high potential is applied and the releasing of electron happens, and this emitted electrons will flow towards the workpiece and it can able to join there. It means heat is generated, automatically electrode will be communicated. So the summary, in welding we have seen about the arc initiation methods, and in this arc initiation we have seen about the touch method and then the field start, right? And also we have seen about these various methods of arc, how this negative polarities we have seen. The remaining part of the subjects we will see you in the next session. Thank you.